We are going to be reviewing how to label the characteristics of a graph. So this first graph is an absolute value equation. And if I look over here, notice to the left of my graph, this is actually going off to negative infinity. To the right of my graph, this is going to positive infinity. The bottom of my graph goes down to negative infinity. Up here goes to positive infinity. The first characteristic of a graph is its domain and range. So domain is my inputs. What is the furthest to the left my graph goes? And as I go to my left, notice there is no endpoint. This arrow, that arrow means it keeps on going. So if there's no endpoint, there's an arrow that keeps on going. The left of my graph, it goes to negative infinity. I can never reach infinity, so it's less than x is less than. To the right, my graph keeps on going again. The arrow, no endpoint. That arrow means it keeps on going, so it goes to infinity. Range is my outputs. So the lowest this graph ever goes, this is the lowest. And the y value that causes the lowest, range is the one time we're using y values. The y value of the lowest point is -1. This graph does touch -1 right here. So we say less than or equal to. So I start with the lowest, less than, and then the variable less than the greatest. And so the highest this reaches, as I go all the way up, notice the arrow is pointing up. So the arrow keeps on going up, it's going up to infinity. Now remember, we have other notations we could use as well. For example, this first one with domain could have also been written as negative infinity, comma infinity. That is an interval notation. I also could have said all real numbers. The range, I could have just said y, and notice the arrow is pointing at -1 because y is greater than -1. So I could have said greater than or equal to -1 like that. I could have said I reached -1, so I could have used a bracket, -1 to infinity. Okay, and then I could have done set notation, so multiple notations. Now the next thing I want to talk about is intervals of increasing or decreasing. Okay, when we're talking about increasing or decreasing, I want you to think of going for a walk. And we always start on the left of our graph, just like we read a sentence. We're going to start on the left of our graph over here. And so I start on the left of my graph, and I'm going to go for a little walk. If my computer stops glitching. Alright, I'm walking left to right. I cannot just walk left into the air. So I'm actually going to be walking down, 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 down. I am walking down. Since I am walking down the hill, this area is decreasing. I then take a little break on my walk. I have reached the bottom. I have reached the bottom. I have stopped decreasing, so I am now at a minimum. I am now at a minimum. And now I have to start walking up, 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 up. And I keep walking up forever. So where did I stop, take my break at? I stopped and took a break at the x value of -2. So my walk started, so let's see, this interval was decreasing. So I have my increasing interval and my decreasing interval. And the decreasing interval started at negative infinity. So I never reached negative infinity. I go for my walk, and then I take my break. I reach the bottom at the x value of -2. Intervals are x values. Intervals are x values, not the y values. Now that I'm done decreasing, I start increasing. So -2, I start increasing. And I keep increasing forever. Okay, so that is intervals of increasing and decreasing. The next one I'm going to do on the next problem, I'll just look at positive and negative values. I'll look at positive and negative value. Okay, so I have this absolute value equation. So again, to the left over here, so this actually has an arrow going on. This goes to negative infinity in this direction, infinity over here, negative infinity down here, infinity up here. My domain, what's the furthest to the left this graph is ever going? Negative infinity. What's the furthest to the right this graph is going? Positive infinity. Range. And when I say the graph, I'm not talking about your xy coordinates. I'm talking about this red line. The red line keeps going to the left, keeps going to the right. Now for range, the lowest it ever goes, notice the arrow's pointing down. So the lowest it ever goes is negative infinity. So you start with the lowest. Less than y, okay, y, range is a y value. And then it goes to a highest point. This highest point is 1, and it does reach 1, so it is included. So now let's talk about positive or negative values. We have a barrier of the x-axis that separates positive and negative values. Everything above the x-axis, these are positive. These are positive values. So the x-interval that is above the x-axis gives us positive value. These values down here, these are negative. Okay, they are below the x-axis, so they are negative. And so again, I am looking at the x-interval. So I start from the left of my graph. And notice these values along this portion until here, these are all negative. So they start being negative over here at negative infinity, and then they keep being negative until the x value of 0. At 0, it goes above the axis, and it keeps being above the axis until 2. So from 0 to 2, it's above, so from 0 to 2, it's positive. Then we reach the x-axis again. Then we go below the axis, so it's negative again. So up here it was positive, and these two sections down here are negative. And it keeps being negative up the arrow to the right. Since it keeps going to the right, it's infinity. Again, I am looking at the x values that cause this to happen. So my graph is positive. Oops. Okay, so my graph is positive just between this section here, just between this segment here. So it starts being positive at 0, and again I'm listing x values, and it keeps being positive until 2. I do not include the endpoints in this situation because the endpoints are a value of 0. And a y value of 0 is neither positive nor negative. Now when I talk about negative values, negative interval, my first interval starts at negative infinity. And it keeps being negative. So from negative infinity, as I go to the right, it keeps being negative until the x value of 0. I can write the word and. I'm combining two intervals. There are two different intervals. So I can either write a word, or there's this thing called a union symbol. It looks like a U. And this U means I combine both of these. It could be in this interval or this interval. Okay, so it's bringing together those two intervals, saying that both those intervals are solution. And so my next interval starts, the left value of that interval is 2, is less than x, is less than, and to the right of the graph, it keeps going to infinity. Alright, let's try this on another problem. On the next problem, we will label everything: domain, range, increasing, decreasing, positive, and negative. So this graph I'm going to give you now is a parabola. So to start with the domain, the graph to the left, it keeps going, it keeps going, it keeps going. Okay, this arrow is pointing slightly to the left and up. So to the left, it keeps going to negative infinity. Less than x, less than. To the right, this graph doesn't stop right here. This arrow means it keeps going. I could keep drawing that on and on and on. So I say it goes to infinity. Range. Range are my y values. The lowest this graph ever goes is -4. And it does reach -4. And these are my y values. And then it keeps going up, 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 up forever, less than infinity. Now let's figure out increasing and decreasing. Remember, these are going to be x intervals. So I have something less than x less than. Alright, so I start on the left of my graph. I always start my walk on the left of my graph. And in this graph, I'm going to start by walking down. So I start on the left at negative infinity and I'm going down. So I put that under decreasing. And I keep walking down until I reach my bottom point. This bottom point is called a minimum. And this happens at the x value of -3. So I'm done decreasing at -3. I take a little break and I start walking up the hill. So I start increasing at -3. And I keep increasing. Well, the arrow on the red line goes on forever. So I increase to infinity. Okay, positive. It is positive when it is above the x-axis, when it is above this line. So over here on the left at negative infinity, it's above the line. And then these are x values again. It keeps being above the line, it keeps being above the line until I reach -5. Now it's no longer positive. But I see that there's another area that's positive, so I'm going to combine it, I'm going to union it, I'm going to combine, and this next section starts at -1. And then it keeps being positive to the right forever, to infinity. Negative is when it's below the graph. So if I look at -5, it goes below the graph. It starts going below the graph. So -5 is the start of my negative. And it keeps going until -1. It keeps being negative all through here, and then at -1, it stops being negative. Okay, keep in mind, all your intervals need to go from smallest to largest. Let's do one more problem. Okay, I have this parabola. Okay, domain. Domain of all parabolas stays the same. If it's a function, it's -infinity to infinity. So my domain is still -infinity to infinity. Even though you can't see the values over here, you don't see the graph over here, this red line means if I drew this graph big enough, you would see it keep going. So keep paying attention to those arrows. Now range. The lowest this graph ever goes, it has arrows. So the lowest it ever goes is -infinity to y, and the highest it ever goes is this maximum here, this highest point of -4. And it does reach -4, so I have to say or equal to. Increasing and decreasing. I'm going to start my walk on the left of my graph. I always start my walk on the left of my graph. And this time, notice I am walking up my graph. This time I start by walking up until I reach my maximum. So to the left over here, I was at -infinity, and I'm walking up the graph, so I'm increasing. And I keep walking up the graph until the x value of 5. Again, these are x values. Now at 5, I start going down the hill. Now I start to go down. And now that I'm going down the hill, I am decreasing. And I keep decreasing infinitely. positive. And guys, notice none of these examples had constant. Something would have been constant if it had a slope of 0. If you had a horizontal line, that would be a constant interval. And these curves do not have constant intervals. Okay, now positive. Positive is when it's above the x-axis. But notice, it's never above the x-axis. So there is no interval, none, or don't say 0. You can say the null set. This is called the null set, which is this set notation, and that's the null symbol. It looks like an O with a line through it. It is negative. Well, it's always below the x-axis. So it's negative for all real numbers. Or you could have said negative infinity to infinity. Let's add on one more piece to this last problem. In behavior. You only have in behavior where there is an arrow. So if there are 2 arrows, you have 2 lines of in behavior. If there's only 1 arrow on the graph, then you only have 1 point of in behavior. So on this graph, our standard setup is as x approaches infinity and as x approaches negative infinity. This graph does have an arrow in both the left and the right, so I will use both of these. These are sentences, they are statements, so write them as such. So as x approaches infinity, comma. And then what is y doing, or what is f of x doing? So x approaching infinity, that's to the right of the graph. What's happening to the right of the graph over here? As I go to the right, my graph goes down. So we say y approaches negative infinity. As x approaches negative infinity, that's my left. So as I go to the left of my graph, what is my y doing? My y is going down. So I say y approaches negative infinity. And that's all for today.